Hello everyone, my name is Jalin Raipar. I'm from Bilkent University from the Departments of Molecular Biology and Genetics. In this video, I'm going to introduce you the experiment that I've done for my Physics 102 lab project. First of all, my aim was to evaluate the Kirchhoff's first rule, which is also known as the Junction rule. And this rule basically suggests that the sum of all the currents entering in a junction is equal to the sum of all the currents leaving the same junction. To evaluate this rule, I've designed 4 setups as you see. In these setups, we both have the circuits that are connected only in parallel, and we have circuits containing resistors that are connected in both parallel and series. For designing this experiment, what I needed was a multimeter, 5 identical resistors, a power supply, and cables to connect and set up the circuits shown. So I've started my experiment by setting up the first setup with 3 resistors, connecting them in parallel. For the evaluation of the rule, my aim was to insert the multimeter into the circuit in series to measure the currents on each branch. However, due to some problems occurring in the multimeter, I've continued my experiment by inserting the multimeter in circuit in parallel and measuring the voltages on each resistor. Therefore, by Ohm's law, I could still calculate the currents on each wire. I've measured the voltages on each resistor in my first setup and calculated current values for each wire and converted them into milliamperes from amperes. I've completed these steps for each setup, and to reduce the random errors as possible, I've done 3 trials for each setup. After collecting all the data, then I've calculated the sum of the currents of each branch for each setup and trial, and to be able to plot a graph, I've calculated the average of them and plotted a graph accordingly. As you can see, while the expected theoretical best fit line is a straight line with a slope of 1, the calculated values do not generate such a straight line. However, they seem very close to the measured values. At the end of the experiment and the plotting, I had 0.18% error for setup number 1 and 8.87% error for setup number 2. And I had 0.23% error for setup number 3. And lastly, I had 12.71% error for setup number 4. And even though the percentages were considerably small in setup number 1 and 3, there is a lot more errors seen in setup number 2 and 4. And this could be because of the internal resistance of the multimeter itself, or because of the wires. Also because of the loose junctions when measuring the voltages, or due to the connections in the designing of the setups, it could also lead to errors. And also this experiment shows that adding a resistor in a circuit in parallel increases the main current, while adding it in series decreases the main current.